In this video, an extraordinary creation begins to reveal its story. A craft inspired by the sleek contours and bold engineering of the SU35. What begins as admiration for a supersonic fighter evolves into a vision entirely its own. A vessel designed to move with grace across and beneath the water, merging ambition with innovation never before attempted. Construction begins with the skeleton, forming the very foundation of the project. Sheets of Fomex plastic are selected for their combination of flexibility and strength, providing a lightweight yet durable material suited for shaping a composite structure. The sheets are aligned and fastened to create the exact inverse of the final watercraft shape. Every curve, edge, and panel is deliberately positioned to ensure the negative mold produces a perfectly symmetrical and smooth composite shell. This stage demands a refined balance of precision and patience. The skeleton serves as the master blueprint for the watercraft's outer form, capturing both the aerodynamic elegance of the SU35 and the functional requirements of a lightweight hull. Every element of the skeleton is measured and cut to exact dimensions, then positioned within the negative mold. Alignment is verified repeatedly, ensuring all structural forms follow the contours of the mold with complete accuracy. Using plastic boards to construct the skeleton for a positive pattern, or plug, is a highly efficient method in professional composite fabrication. This technique establishes the complex three-dimensional geometry of the final product with remarkable accuracy before molding work begins. The internal skeleton's primary function is to provide a rigid, lightweight armature that defines both the plug's shape and its structural integrity. This framework ensures strict symmetry and precise adherence to the original SU35 design specifications throughout. The skeleton serves a critical support role, functioning as a structural base capable of bearing the weight of putty, fairing compounds, and smoothing materials applied during the later finishing stages. For the builder, working with plastic boards enhances efficiency by enabling rapid cutting and assembly of cross-sections and stringers, replicating the intricate internal lattice structure found within an actual combat aircraft. The creator's foremost challenge is faithfully recreating the aircraft's aerodynamic profile and adapting it to function as a capable hydrodynamic vessel. A thorough understanding of the original aircraft is essential, as every element is crafted to closely replicate the SU-35. The aircraft is a highly advanced single-seat, twin-engine, super-maneuverable multi-role fighter developed by Russia, widely regarded as a fourth-generation plus-plus platform. Its design is defined by enhancements in aerodynamics, raw power, avionics, and superior structural integrity. The wings are substantially reinforced, while the horizontal tails and vertical stabilizers are enlarged to improve stability and control. The blending of wing and fuselage, known as aerodynamic coupling, is refined, enabling the fuselage to generate considerable aerodynamic lift. The SU-35's defining characteristic is its extraordinary maneuverability, made possible by its highly advanced propulsion system. For this reason, the twin-engine configuration is essential for the watercraft to remain faithful to its legendary fighter inspiration. If you are following along and finding value in this build, please take a moment to like the video and subscribe. Your continued support is genuinely the most meaningful way to encourage the creation of future content. The aircraft's three-dimensional thrust vectoring system, enabling it to redirect thrust across 3 axes, cannot be directly replicated in a waterborne environment. However, the twin-nozzle engine bay is precisely shaped to preserve the fighter's unmistakably aggressive visual presence. The SU35's iconic design relies fundamentally on its wide, flat central fuselage. This broad blended configuration serves far more than aesthetics. It is essential for generating the aerodynamic lift that sustains the aircraft in flight. In the watercraft, this wide and flat lower surface is deliberately preserved, though it serves a different purpose. It provides a generous planing surface that allows the vessel to ride efficiently and powerfully across the water at high speeds. The builder must carefully maintain the precise angles and sweep of the wing roots so the fuselage transitions seamlessly from nose to rear. This ensures both the authentic visual accuracy of the SU35 and the high-speed planing performance of the watercraft. With the structural framework and forward section completed, attention shifts to constructing the hull. Sheets of FX plastic are assembled and secured, progressively transforming the skeletal plug into a solid and continuous structural form. The precise installation of the nose cone brings the assembly to completion, converting the skeletal framework and plastic boards into a fully formed hull. With the primary structure finished, the craft advances into the next phase. To achieve a smooth finish and prepare the hull for composite layers and final coatings, body filler is carefully applied. The process begins at the joints and screw holes, where small gaps and imperfections are most visible. Multiple layers of filler are applied methodically across the entire hull. Once each layer has cured, the surface is sanded to remove all excess material, ensuring the hull's precise contours and flowing curves are faithfully maintained. A water-based release agent is applied uniformly across the surface to prevent the composite layers from bonding to the mold. This allows the resin and fiberglass layers to be applied cleanly and later removed without damage. A durable, scratch-resistant gel coat is applied to form the inner surface of the mold. A specialized tooling gel coat is built up in several layers and allowed to cure until it reaches a firm yet slightly tacky consistency. Alternating layers of fiberglass and resin develop the full structural strength and thickness of the mold. While the gel coat remains tacky, the first layer of fiberglass mat is positioned and saturated with resin, with rollers used to eliminate trapped air bubbles. Silicone-coated fiberglass fabric is applied, forming one of the key structural layers of the composite hull. This material is selected because it releases cleanly from the mold while providing a stable base for all additional layers. With one complete side of the mold finished, construction continues on the opposite surface of the hull, following the same methodical sequence to ensure perfect and consistent structural integrity across both sides. The newly exposed surface is treated with a water-based release agent applied uniformly across the entire area. This coating guarantees all subsequent composite layers will release cleanly once cured, protecting both the mold and the finished hull. Once the release agent has dried, the surface is carefully sanded to achieve a smooth and uniform finish. Water is introduced to dissipate heat generated by friction. Wet sanding reduces dust and maintains a consistently clean working surface. While the gel coat remains slightly tacky, the fiberglass mat is laid carefully into position. The subtle adhesiveness of the gel coat allows the fabric to settle naturally and conform precisely into every curve and contour. After the silicone-coated fiberglass and all subsequent composite layers have fully cured, the entire structure is prepared for separation from the temporary internal framework that supported it throughout construction. The fully cured fiberglass shell, now rigid, stable, and holding its precise aerodynamic form, is carefully lifted away from the internal plastic board support structure built earlier. This critical step produces the finished negative mold, ready for all subsequent work. Gray gel coat is carefully brushed onto the interior surfaces of the negative mold, ensuring even coverage across every curve and edge. This layer forms the definitive outer surface of the watercraft, delivering both durability and a polished appearance. Once applied and allowed to reach a slightly tacky state, the surface is prepared for the following stages of lamination. Beyond its aesthetic role, the gel coat shields the hull from water exposure, ultraviolet radiation, and operational wear. Steel reinforcement components are installed at all critical structural points, including engine mounts, propeller housings, and framework attachment zones. A bonding agent is carefully applied to secure each insert, ensuring a strong and completely immovable connection. All excess material along the front nose cone mold is trimmed back, and the two mold sections are precisely aligned and secured with screws. This produces a stable assembly serving as the foundation for constructing the forward section of the watercraft body. Gray gel coat is meticulously applied to the negative mold of the nose cone. A layer of fiberglass mat is then positioned over it and fully saturated with resin, forming the first strong and rigid layer of the forward hull section. The tail fins, serving as vertical stabilizers in this SU35 inspired design, are constructed following the same precise multi-step fabrication process. Every stage is carefully executed to guarantee both structural integrity and authentic visual fidelity to the original aircraft. Rather than sourcing new components, the project embraces a sustainable approach by restoring two salvaged propeller units. Each propeller assembly is fully disassembled, providing complete access to all internal components for thorough cleaning and repair. All components are meticulously cleaned, sanded, and polished to a refined finish, fully restoring smooth mechanical operation. These units generate thrust by drawing water through an intake, accelerating it through a spinning impeller, and expelling it as a high-velocity jet through a steerable nozzle. Two reconditioned 650cc Kawasaki engines are carefully positioned within the reinforced mounting points integrated into the hull. Originally engineered for personal watercraft, these engines are recognized for their proven reliability, compact dimensions, and impressive power-to-weight ratio. The exhaust system is fully integrated to optimize engine performance and ensure safe operation. It efficiently directs combustion gases away from both engines while managing temperatures, reducing noise, and maintaining the back pressure necessary for optimal power output. Once all technical adjustments have been completed and verified, the upper section of the vessel reaches its final point of completion within the negative mold. The result is a fully formed composite shell, structurally sound, cleanly contoured, and ready for all subsequent stages. Thanks to the thorough earlier application of both water-based and wax-type release agents, the demolding process proceeds in a smooth and controlled manner, allowing the complete shell to detach cleanly without any damage. The following stage focuses on preparing the vessel for upcoming mechanical installations. 2 precise cutouts are made in the rear section of the hull, marking the beginning of the customization phase that will house essential components and future upgrades. Precisely located holes are drilled into the hull to serve as secure attachment points for the removable wing system. Each location is selected to ensure correct balance distribution, bilateral symmetry, and adequate structural support throughout. The wing assemblies undergo the same drilling process, with matching holes produced to identical diameters. Rigid pipes are inserted through the openings, functioning as strong supports that lock the wings firmly in position while still permitting easy removal when required. A defined section of the wing is carefully trimmed and shaped to form the movable control surface known as the elevator. This essential component provides accurate control over the craft's pitch, the nose-up or nose-down rotation around its lateral axis. The main section of each wing is coated with gel coat and sanded to eliminate minor surface imperfections. The joint between wing and body is carefully filled and faired, creating a smooth and continuous surface that improves aerodynamic efficiency by reducing turbulence. The next phase involves installing the rear wings, engineered to function as primary stabilizers. The process closely mirrors the procedures applied to the side wings, with the key distinction that these wings are designed to be fully movable, providing enhanced maneuverability and precise directional control. To achieve this range of motion, the internal structure of each rear wing is reinforced with carefully positioned support pipes. These pipes function as precision pivot shafts, enabling the wings to rotate smoothly while withstanding water pressure and dynamic loading forces. With this step successfully completed, the craft is now equipped with a fully functional set of rear stabilizers. Attention now advances to the installation of the tail fins, which serve as the primary vertical stabilizers of the finished watercraft. To faithfully preserve the authentic silhouette of the original aircraft, precisely crafted small external components are carefully added to the fins, accurately representing the radar warning receiver housings found on the actual SU35. The following phase is dedicated to creating the mold for the watercraft's canopy, the transparent enclosure that will define the operator's cockpit profile. The process begins with constructing a precisely shaped skeleton mold to accurately capture the distinctive curvature of the canopy. Plastic boards are selected as the primary material for the canopy skeleton. A layer of body filler is applied over the assembled framework and sanded smooth. Fiberglass fabric is then conformed to the prepared skeleton surface, producing the desired aerodynamic canopy profile. Thin structural profile strips are cut and bonded directly onto the fiberglass shell in precise locations. Each strip is positioned exactly where the genuine SU35 canopy features its characteristic framing lines, faithfully replicating the distinct visual framework of the original cockpit glazing. The temporary mold profile strips are carefully removed, leaving behind a perfectly shaped indentation across the canopy surface. This recessed channel is subsequently refined and finished to achieve a consistent and precise depth throughout. This newly formed recessed channel functions as the structural glazing frame, providing the exact space required for installing the transparent acrylic sheeting that will form the actual cockpit glazing of the finished canopy. Acrylic sheet material is widely favored in aircraft manufacturing as a proven lightweight alternative to glass. It offers outstanding optical clarity, ensuring the operator will benefit from a completely clear and unobstructed forward field of view. The acrylic sheets are carefully heated and shaped to fit perfectly within the prepared glazing channel. This ensures a seamless and aerodynamically clean integration between the transparent panels and the surrounding fiberglass canopy frame. The canopy shell is carefully removed and separated from the molding skeleton that defined its shape throughout fabrication. The demolding operation must be performed with exceptional care to avoid any damage to the delicate fiberglass frame. All excess fiberglass material is trimmed away from the canopy shell perimeter. Corresponding cutouts are then carefully made in all areas that align directly with the prepared glazing channels to receive the transparent acrylic panels. Attention now turns to the construction of a fully functional landing gear system. These assemblies allow the watercraft to be rolled and maneuvered across solid ground when out of the water. Every component, the main struts, axles, and wheels, is engineered to support the full structural load and facilitate smooth ground movement. The front landing gear assembly is carefully constructed and integrated into a robust and fully operational unit. The primary shock-absorbing strut is precisely mounted to manage vertical loads and absorb any ground surface irregularities during movement. The axle is fitted with precision bearings, enabling both front wheels to rotate freely and smoothly. Once the wheels are installed and secured, the front gear assembly is ready to guide the entire craft confidently across any ground surface. The next critical step involves ensuring long-term smooth operation by applying a high-grade lubricant to the strut mechanism. This reduces internal friction, prevents premature wear, and ensures the suspension system operates with complete freedom of movement. The rear landing gear assemblies bear primary responsibility for supporting most of the watercraft's structural weight. It is essential that these twin assemblies are installed with perfect evenness, as any imbalance could compromise the vessel's stability and ground stance. Unlike the front landing gear, the rear assemblies incorporate dedicated trunnions and structural bracing. Working together, these elements ensure the main rear gears maintain their exact geometric alignment, providing the stability essential for safely supporting the watercraft under full operational weight. Attention now shifts to the mechanical heart of the watercraft, where the twin Kawasaki two-cylinder two-stroke engines are carefully prepared for their demanding role. Each engine is thoroughly washed and cleaned to remove all residues and debris from previous use. The carburetor assemblies, vital components responsible for mixing air and fuel, are fully prepared and finished in matte black, while the complete engine exterior receives protective paint, restoring each unit to a crisp and factory-fresh appearance. Before the jet drive pump components are assembled, the designated mounting area within the hull is carefully painted and prepared to receive all fittings. These include the main pump body and the steerable thrust nozzles, which provide directional control for both forward propulsion and reverse maneuvering. The jet propulsion system generates forward thrust by drawing water into the pump intake and expelling it at high pressure through a precisely directed nozzle. By projecting water rearward at high velocity, it produces an opposing reaction force that drives the vessel forward. To complete the electronic control system, the servo controller boards are prepared and installed to manage the high-torque servos operating all critical control surfaces. Each board functions as a dedicated power distributor, isolating the high current demands of the servos from the sensitive low-current electronics of the primary control system. The remote control system is configured using a professional-grade radio link transmitter paired with an R9DS receiver, both connected through a motor driver board for stable signal transmission. This configuration is ideal for projects demanding simple, dependable, and responsive motor control. To create a solid mounting base for the steering actuator, a precision-machined metal plate is selected as the foundation platform for the high-torque servo unit. Several metal components are carefully welded to this plate, forming the complete structural foundation and articulation points for the steering linkage. A purpose-built metal control arm and wing nut assembly are firmly mounted to the thrust nozzle. The control arm is then mechanically connected to the servo assembly, functioning as the primary lever that receives and transmits directional motion from the servo directly to the nozzle. When the servo actuates, the complete linkage system transmits this force to the nozzle control arm, pivoting it smoothly from side to side to redirect the high-velocity water jet and provide accurate and responsive steering control throughout all operating conditions. The final stage of mechanical integration involves carefully connecting the reconditioned Kawasaki engine to the exhaust routing system, ensuring all combustion waste gases are efficiently directed away from the engine compartment and expelled clear of the vessel. The next essential undertaking is the full construction and integration of the complete fuel delivery system designed to reliably supply the reconditioned engine. This carefully executed process ensures a consistently clean and completely leak-free fuel supply under all conditions. The process begins with assembly of the fuel tank, constructed using a series of interconnected tubes arranged in a segmented configuration, specifically shaped to fit precisely within the unique internal contours of the hull. A high-quality inline fuel filter is mounted along the delivery line, ensuring only clean fuel reaches the carburetor and protecting all sensitive internal engine components. The complete fuel line routing is carefully adjusted and secured to guarantee reliable operation throughout. The ailerons, critical wing-mounted control surfaces responsible for managing the craft's roll attitude and lateral balance, are carefully attached to the wing structure using precision hinges, ensuring they articulate freely through their complete range of motion. The watercraft is now fully prepared to receive its most visually defining feature, the striking two-tone camouflage livery comprising light blue and crisp white, faithfully replicating the iconic paint scheme of the genuine SU35 fighter jet. The initial coat of light blue is applied evenly across the entire hull. A precisely executed camouflage pattern is then applied using professional masking techniques, creating sharply defined designs across the fuselage, wings, and stabilizers, reproducing the hard-edge transitions characteristic of modern military combat aircraft. If you have followed this journey all the way to the very end, we want to offer our most sincere and heartfelt thanks. Your dedication genuinely means everything to everyone involved. You represent our most committed and valued viewers, and your ongoing support is deeply appreciated. We are committed to raising the standard with every video. If this build inspired you, please like and subscribe. It supports us more than you realize. Thank you sincerely. All systems and components are subjected to comprehensive testing before any water launch is attempted. Every aspect of the servo control system, every signal from the remote transmitter, and every movement across all steering and thrust mechanisms is methodically verified. Each command is tested to confirm it translates into precise and fully reliable motion. The SU-35-inspired watercraft now stands fully constructed and completely prepared for its long-anticipated maiden-water trials. It sits poised and ready to fulfill its creator's original vision, engineered to skim powerfully and effortlessly across the river's surface, precisely as first imagined. From the meticulously crafted fiberglass cabin structure to the robust dual propulsion system, every component stands as a testament to the exceptional dedication, refined craftsmanship, and unwavering passion invested throughout every stage of its construction. After countless hours of skilled craftsmanship and absolute persistence across every challenge encountered, this remarkable project has finally reached its triumphant completion. What began as nothing more than a bold idea has now taken magnificent shape as a breathtaking operational reality. This watercraft represents far more than the sum of its mechanical components. It is a powerful physical expression of a dream. Raw materials transformed through determination, creativity, and unrelenting commitment into a fully functional and genuinely artistic creation, unlike anything attempted before. Every component reflects a challenge that was identified, confronted, and ultimately conquered. Each one a deliberate step forward, and a reminder that with sufficient commitment, even the most audacious dreams can be brought to life. Flying across the water with the untamed spirit of a fighter born from open sky. It glides just above the river's surface with the effortless grace of a combat aircraft in open flight, perfectly capturing the very essence of high-speed aerial movement while carving its own powerful and distinctive path through the water below.